Hi students, uh, this is Ramesh Reddy, chemistry faculty. Now today Neet exam 2025 is completed. Regarding the exam, we are going to discuss the key in the paper of chemistry. First question, so 46, identify the suitable reagent for the following conversion. Look at this question here. In this question, the functional group is the ester. It is the COOCH3. Ester is going to converted into aldehyde. So here ester is converted into aldehyde. There is usually a selective reducing agent, that is the diol. Diisobutyl aluminum hydride. So that is the chemical formula for aluminum hydride. It is the 2 is the diisobutyl followed by hydrolysis. Ester is converted into aldehyde. Second question, the correct order of decreasing acidity. So acidic strength of the following carboxylic acid. Now acidic strength directly proportional to negative inductive effect, inversely proportional to positive inductive effect. Regarding here, formic acid is the more. Here CH3 plus I effect. Plus I effect is the inversely proportional to acidic strength. Here 2 CH3 groups are the plus effect increases. Here 3 plus I groups, 3 CH3 groups are more plus I effect, that has the less acidic strength. So first one is the correct acidic strength order. Next one, 48 question. Which one of the following reactions does not belong to Lassagne test? Lassagne test, it is the sodium fusion extract formation from the given organic compound. Here cuprous oxide with carbon reaction is not be done. This reaction is the estimation of carbon of the reaction. So this is not going to be Lassagne test reaction. Sodium should be present in the Lassagne test, not the here cupric oxide. So second one is not in the Lassagne test. So 48 question option 2. Third one, next one, 49th question. It is regarding the chemical kinetics. If the rate constant of a reaction 0.03, second inverse. So here rate constant, second inverse are units. So it is the first order reaction. How much time does it take for 7.2 moles per liter concentration of reactant to get reduced to 0.9 moles per liter? Let's see this question. Now 49th question. Here first order equation. In first order equation, K equal to 2.303 by T log A by A minus X. Here T equal to 2.303 by time is given 0.03 log initially the 7.2, final reduced is the 0.9. So 98. This is the 2.303 by 0.03. Log 8 is going to be log 2 keep. This is the 3 log 2. Now 2.303 by 0.03 into 3, log 2 value 0.3. Now here 0.1 is remaining. So 2.303 into 3, 339, 339, 326. Already point here downward, it is going up. Now we are getting the 69.09. So approximately the given key is the 69.3 second. It is the option 3. Next one, question number 50. In question number 50, statements are given. Two statements. Statement 1, a hypothetical diatomic molecule with bond order 0 is quite stable. Actually, bond order means number of bonds present between the two atoms in molecule. Here bond order 0 means the molecule is not going to be existed. So it is the statement 1 is the wrong. So statement 1 is the incorrect. And statement 2, bond order increases, bond length increases is given. Actually bond order inversely proportional to bond length. So bond order increases, bond length decreases. Here both statements are false statement. So that is the option 4. Here both statement 1 and 2 are false. Next one, let's come to the 51. Out of the following complex compound, which of the following compound will be having the minimum conductance? So minimum conductance, so number of ions directly proportional to conductance. Number of ions increases, conductance increases. Have a look at now first one. This complex is going to be have the 3 chlorine atoms outside. Total there is the 4 ions. Here 1 chlorine outside, it is the 2 ions. Total this complex is going to be single ion consider. That is the 1. Here also 1. So here this is the minimum conductance having the minimum ions. So 3 and 4 both are the correct answers. So either we can keep the 3 or 4, we can get the marks. So 3 and 4 both are the correct one. Next one, 52. It is also given regarding the solution chapter. Which of the following aqueous solution will exhibit highest boiling point? So highest boiling point is going to be here boiling point directly proportional to number of ions and directly proportional to I, 1/2 factor. Here total ions we are going to consider. In the first one, it is the 0.01 mole in Na2SO4. Here 2 sodium ions, 1 SO4 minus 2 ion, total 3. That is the 0.03 ions. Next one, it is the glucose. Glucose is a non-electrolyte. Here total it is considered 1 molecule. It is the 0.015. It is equal to same 0.015. So urea also non-electrolyte. It is the same 0.01. KNO3, K plus NO3 minus 2 ions. It is the 0.01 into 2. It is 0.02. Here maximum boiling point is going to be option 1, 0.01 molarity Na2SO4. Next one, 53. Assertion reason question. Here SN2 reaction. So obviously SN2 reaction, it is going to be methyl halide, primary, secondary, tertiary. Here in halides, I minus greater than Br minus Cl minus. I minus is the best leaving group, iodide ion. So that's why in assertion, iodide chlorine, iodide compound undergoes SN2 reaction faster than chlorine compound. It is correct. Here reason is given, iodine is the better leaving group because iodine is the large size. So both A and R true. R is the correct explanation of A. So it is the 3. Next one, consider the following compound. In the underlined atoms oxidation states are given. Here KO2, it is the superoxide, but there is asked potassium. Potassium always first A group +1. And H2O2 hydrogen peroxide O2. So in a H2O2, oxygen is the peroxide is the -1. H2SO4 sulfur is the +6. It is the +1 -1 plus 6. It is the option 3 is the correct. Next one, it is the matching bit is given regarding the catalyst. In the regarding the catalyst, Haber process, we know the iron catalyst. Waker process, palladium chloride. Wilkinson catalyst, it is the triphenyl phosphine rhodium chloride compound. It is the 3. Ziegler-Natta catalyst, it is the titanium tetrachloride with the trimethyl aluminum. That is the matching A1, B2, C3, D4. So that is the option 1. Next one, 56. Given statements like nitrogen that can form ammonia, arsenic can form arsine. S, so nitrogen with hydrogen NH3, nitrogen, phosphine PH3, arsenic ASH3. This is called arsine. They can form trihydrides. But in the statement 2, antimony cannot form antimony pentoxide. Here, nitrogen, phosphorus, arsenic, antimony, bismuth. Now, there is an electronic configuration NS2. It is the 5th year group NS2NP3. When you can come to the down, +3 state is the stable due to inert pair effect. So antimony is the Sb, antimony pentaoxide, antimony trioxide. In the trioxide is the +3 state, pentaoxide is the +5 state. Antimony is the +3 state is the more stable regarding the inert pair effect. So that's why antimony cannot form the pentaoxide. So it is formed, but it is a temporary. It is a cannot form. Okay. So that's why statement 2 is the incorrect. Statement 1 is the correct. Now that is the here in the paper. First one, statement 1 is correct. Statement 2 is the incorrect. 57. In the also given statements, ferromagnetism. Ferromagnetism is considered as an extreme form of paramagnetism. So paramagnetism means partially attraction is present between magnetic properties. In magnetic properties, there is a partial attraction is present. Ferromagnetism is the strongly attraction. So here, strongly attraction by magnetic field. So paramagnetism is the partially attracted, that is a weakly attracted. This attraction extension. So it is the attraction extension is the ferromagnetism. So that's why ferromagnetism is considered as the extreme form of the paramagnetism. It is the correct statement. In the statement 2, chromium +2 and neodymium +3 having the same number of unpaired electron. Let's go into check. Here chromium atomic number 24, outermost electronic configuration argon 3d5 4s1. In chromium +2, it is the 2 electron, 1 electron from 4s, 1 electron from 3d, it is 3d4, means here number of unpaired electrons 4. But in the neodymium Nd, neodymium atomic number 60, it is the xenon 4f4 6s2. Here neodymium +3 is given. Now here xenon 3 electrons are losing from 6s2 2 electron, 4f 1 electron, then remaining 4f3. Here n equal to 3. So same number of unpaired electron not present. So here statement 2 is the false. Statement 1 is the correct. Statement 2 is the false. So here in the regarding paper, option 1 is the correct. Next one, 58 question. Which one of the following reactions does not give benzene as a product? Here it is the acetylene. It is the trimerization takes place in presence of red hot iron tube. It gives the benzene. It is the diogenium chloride compound in presence of water warming. It gives the N2 is eliminated. Now it gives the phenol. the product is the phenol, not benzene is formed. Now it is the decarboxylation, benzene is formed. It is the N-hexane aromatization catalyst. In the aromatization, it gives the benzene C6H6. Next one, 59. In the matching regarding the noble gas compound, XCO3, it is the pyramidal sp3 regarding one lone pair is present. XCF2, it is the sp3d linear 3 lone pairs present. And XCF6 we can see sp3d3, it is the distorted octahedral. XCOF4 sp3d2 square pyramidal. Now A2 B1 C4 D3, it is the option 3. Next one, how many products including stereoisomers are expected from monochlorination of the following compound? Have you see the monochlorination means only one chlorine we have to substitute in the place of hydrogen. How many possibilities are going to be present? Here we have to check the types of hydrogen. So these two hydrogens are connected to the CH. It is the A type you can consider. It is the B type, C type, D type. But this carbon when replaced by the chlorine, it can show the chiral. This is also can show the chiral. So here this chiral can show the 2-1. So A type 1, B type 1, C type 2 form because chiral, D type also 2, total are the 6. So option 2, 6 monochlorination derivatives are formed. So these are the questions. Look at now 46 to 60 questions. In the next slot I will explain you 61 to remaining questions. Okay, thank you students.